Hello, and today we are looking at comparing prices, just comparing a lot of different things, speeds, gas mileage, things like that. And again, those things are all unit rates. So if you've ever been to the store, like at Kroger, this looks more like a Walmart tag. They'll tell you how much whatever it is you're buying cost. Here it's 2 different boxes of Honey Nut Cheerios. And it says, the grocery stores have made us lazy mathematicians. Why? Well, look at that thing and tell me why. Tell yourself why. And yes, you've probably figured it out. They go ahead and tell us what the price is per ounce for each of these so we can compare the two. Now, initially you might look and say, well, that's the better buy, it's cheaper. But if you look closely, it's only 12.25 ounces. This one's a little blurry. And then this one over here is 17 ounces, so this is a bigger box. Some people get tricked into thinking bigger box, better deal. That's not always true. I think retailers have realized people go for the bigger, and so now sometimes I think they price them higher just so they can get some money out of us. But with that said, it's good to be a mathematician when you go to the store. So sometimes they have their unit prices wrong also, and I've caught grocery stores doing them wrong. So we're going to set up the 2 ratios we need so to see how they calculated this. Hopefully you already know how they did that. That one's really hard to see, but we'll get the exact price so you'll know, our unit price. So in order to compare these, if we look at the 17-ounce box of Cheerios, it's $5.69. So that's going to be $5.69, and we're comparing the ounces, so that'll be for 17 ounces. And labels, labels, labels on everything. You can't label too much. Okay, and so then the 12.25 box is $4.69. So we'll put over 12.25 ounces. So we want to compare these two. And so the best way to do that, well, the way we always do things like that, is we get a common denominator. But the best denominator to get, since we know unit rates, as in dollars per ounce, miles per hour, feet per second, miles per gallon. Anyway, getting the denominator 1 makes it very easy to compare the numerators just like they did here, because per ounce means per 1 ounce. So we'll divide the numerator and denominator by 17. And when we do that, we will find out that this one is, it really is 0.33, and I think you have to round it, but it's 0.33 something, either 4 or 5, and then you round it, and went 1 extra past the pennies, and then down the bottom we have 1 ounce. And then in this one, we're going to divide both by 12.25. And 469 divided by 12.25. Probably already have it. I need to get my calculator out there. It is, oh, I messed up there. Okay, so that is 469 divided by 12.25 is 0.3828. So we're just going to say 0.383 cents per 1 ounce. And I think that's what they've got there. It's hard to see, but yes. Okay, so they don't put it over 1. They just say dollars, get that label on there, per ounce. But that's called a price comparison. They call that a unit price, which is the same thing as a unit rate. Well, now we can see that paying 33 cents, a little over 33 cents, for the bigger box is a better buy than 38 cents per ounce. So down here we can compare unit rates since they have the same denominator, which is, and there's supposed to be a blank there, that didn't show up, is 1. So which cereal is a better deal? The 17-ounce cereal is a better deal. All right, so now let's look at comparing price or any 2 ratios, convert them to their, well, we just said that up there, unit rate. Just trying to really hit that home and decide which one is better. Okay, so for our last one, last example, we have two cars. Car A goes 324 miles on 15 gallons of gas, and car B goes 410 miles on 20 gallons of gas. So here we would look at miles per gallon. Now, be careful because sometimes they might say, is 15 gallons of gas that goes 324 miles, lets the car go 324 miles. They may word it backwards and have the 15 gallons first. So it's not always this one that goes in the numerator. You want to look at your labels and say, what makes more sense, miles per gallon or gallons per mile? And you could do it either way, and you could compare them either way. If you do gallons per mile here, you would do gallons per mile here. But really, what makes more sense that in commercials, things we see, or what we say in the real world, is miles per gallon. So we're going to do 324 miles for 15 gallons, and over here, 410 miles for 20 gallons. So we're going to divide the numerator and denominator here by 15. Now, I do realize, I want you to realize that what you're really doing mathematically, if you divide the same thing out of the numerator and denominator, it makes it an equivalent fraction. Also, this means division this way, so you could say 324 divided by 15, but you have to remember that you've got to keep the miles per gallon there. When I do it this way, for me, it just seems more logical, and safer, because these kind of problems, and I know some of you've done dimensional analysis, when they get harder, it is so important that you look at them as fractions. So we're going to take 324 divided by 15, and we get 21.6 miles per 1 gallon. And over here, we're going to divide 410 by 20, and of course 20 by 20. So 410 divided by 20 equals 20.5 over 1, and that's miles, over 1 gallon. So now when you look at these, you got to think, okay, I'm going miles per gallon, miles per gallon. So which is better? Well, think about, you're driving a car, you're paying for gas. Wouldn't you want the one that goes further on the same amount of gas? This one goes further on the same amount of gas, so car A is better. Now, we've got time. I just want to show you something that you can do it either way. If you had decided to say 15 gallons per 324 miles, that's okay. Just make sure you label and make sure you do the same thing over here. We're going to do it the other way, just so you can see what happens when you compare. Okay, so here we've got gallons per mile, gallons per mile. So now we're going to divide by 324, because that's the denominator. And when I take 15 and divide it by 324, I get 0.0, 4 in the hundredths, and let's just say 0.046, and that's going to be gallons for 1 mile. So that's how much of a gallon I use to drive 1 mile in this car. So now the other one, we're going to divide the numerator and denominator by 410. So 20 divided by 410 equals 0.487, so I'll make that 0.49 gallons for 1 mile. So now when you compare them this way, okay, this time you want to have less gas for the mile. If this one uses less gas than a mile, this one uses more, this is the better deal. So here you're looking at there's more miles in 1 gallon. Here you're looking at you're using less gas in 1 mile. So it's still the better deal. But here you're looking at more, here you're looking at less because of the labels. So just be careful about that. As long as you're consistent and you label, technically it doesn't really matter. In the real world, this makes a little more sense, or it's what we see more, these right here. But it's car A that would be the better deal. All right, how about tomorrow when you come in, I want you to tell me that you love going to the store and looking at unit prices. Have a good evening.